All right, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 50 is on the screen. Shouldn't take you long. Focus, please. Morning, Sean. Okay, you should be just about done, and Angel's going to get us started in a little bit. I'll give you a couple more minutes. All right, share with your neighbor mean, median, and mode for number 1. Then Angel's going to enlighten us. All right, Angel, mean. 2.4. Median. 2. And mode. Hands if you got that. That is correct. So we got our mean, or x bar, 2.4. Q2 is 2. And mode is 2. So I'm just going to label Q2 might as well here. It's 2. So we need a Q1 and a Q3. Pass someone, Angel, or before that, tell your neighbor what Q1 and Q3 are on your box plot before you pass it to someone. Pass someone, Angel. Jeremy, Q1. 1.5 and Q3. That is correct. 1.5 and 3.5. Here goes the process one more time in case you forgot. We got 1, 2, 2, 3, and 4. What's the median? 2, which breaks the data into the bottom half and upper half. So what's the median between these two, guys? 1 plus 2 divided by 2 is 1.5. And this one, 3 plus 4 is 7 divided by 2 is 3.5. The minimum is 1. Maximum is 4. All right. We good with that? Therefore, brings us to the bell curve. Our mean, once again, was 2.4, and our normal range is between the first standard deviation. So, tell your neighbor what you got for the standard deviation, and Jeremy's going to pass it to someone. Standard deviation. Like Bree's got it. Let's go, Bree. All right, standard deviation. Jeremy, pass someone. Alec, you don't got it? Okay, help him out. Bree. Well, what? You don't have it either? What? All right. Go ahead, Ayalani, what'd you get? 3.7. Let's see. The mean. Hold on. Let me pause the twos. The mean was 1.5, so therefore it's 0.5, 0.5, 0.5, 1.5, 2.5. So that means 0.25, 0.25, 0.25, 2.25, 6.25, the 2.5 squared? Oh, I'm getting there, sorry. So this is 8, this is 9.25 divided by 5, bless you, that is 1.85 for the variance, yes? So variance is 1.85, is that correct? So therefore, square root of that, square root of 1.85, that's 1 point what? Approximately, sample standard deviation is 1.36. Yes? Therefore, 1.36 plus 2.4, that's 3.76. And below, that's 1 point. It was 3.7? Oh, I asked for the standard deviation. Be nice. So yes. All right. Woo! That's I'm telling you, the best. Here goes a plug. YouTube, you guys hear me? Best coffee for the price in the valley. Circle K. Let's go. Yeah, they're gonna start sending me royalties, like 10 cents in a little bit. Anyways, agenda. Here we go. Warm-up number 50, measures of position. We're moving on today. And your home plate page, 159, numbers 10 through 11. Or 10 and 11. 10 through 11. So, get a Cornell note ready. I'll give you guys some time for that. All right, here we go. I can summarize data and compute the measures of position. I can summarize data and compute the measures of position. So if you notice, we're no longer in the previous measures. We're moving on. Okay, write that down on your bottom left of your notes. I can summarize data and compute the measures of position. And yes, we're going to finish this week with this before we go to Thanksgiving break. And yes, I do have a study guide that I'm probably going to give you tomorrow. Maybe later on I'll post it on Canvas, just so that you can have a heads up on your semester final. Semester 1 final. All right. Once again, I can summarize data and compute the measures of position. So what are measures of position? We'll get there. So here goes our road map so far. We covered measure central tendency. And what are they? Mean, median, and mode, yes. From there we went to measures of variation. And remind your neighbor what those are, please. What are the measures of variation? All right. What are they, Georgia? Range. Yes, range, variance, and standard deviation. And now we arrive to our last type of measure, known as measures of position. So what are they? Measures of position are commonly used measures to locate the relative position of a number or a data value in a data set. You're like, that's a lot of words, Mr. Q. We'll copy that, we'll break it down a little bit. And also, BTW, FYI, do you notice I did not give you a code today for home plate? Because there was a colleague of yours that they've been asking, Mr. Q, you never give us home plate from the textbook. And we're like, I do. I actually give you home plate from the textbook. They're like, no, you don't. You always put it on the screen. All right, well, today you're going to go to your textbook. Let's go. Woo, from the corner. Let's go. Right? Yeah. All right. So, commonly used measures to locate, pay attention to this word, to locate the position of a data value to a data set. So think about this. You already know how to sketch your bell curve. We already know how to do all that. Now we're going to be looking at how does a certain number of the data set falls within the bell curve at the exact position. That's why these are called what? Measures of position. Okay? Now check this out. Like everything, let me pause the tunes in the back. Like everything, I already gave you a lot of practice with the work needed for this. So it's gonna come in like really smooth. And here they are. The first one is known as standard score. That's something new that we're gonna be looking at today. But we've already talked about percentiles. We're going to revisit those. We've already talked about quartiles. We're going to revisit those. And the last ones that we're going to look at are deciles. These are the 4 different measures of position. 4 different measures of position: standard scores, percentiles, quartiles, deciles. And for non-example, we can put also, again, these. And just FYI, guys, standard scores next to it, I want you to put a parenthesis, and I want you to write the value of Z. So whenever you hear college people or people that are asking you for help in statistics, and they say, do you know how to get the Z-score? Z-score is the same as what? Standard scores. Today we're going to be looking at Z-scores, okay? So, hashtag, just write location of, and I'm going to put hashtag for what? Instead of the word what? A value or number in set. So location of the value or the number in a set. Location of the number in a set. All right? So with that said, example, oh, my bad. Go to your formulas page. Of course, we have new formulas. So formulas for standard scores, here they are. All right? However, before you write them down, look up to the screen. Tell your neighbor what this and this stand for, what this and this stand for, and of course, lastly, what these stand for. Talk to your neighbor, see if they remember what those components stand for. What do those components stand for? I'll give you some time. Go. Start us off down here. What do these stand for? Ethan Aguirre. This is sample, and this is pop. So far, so good. But what else? Yes, standard deviation. That is correct. Damn, Ethan, let's go. If that's true, then what do these stand for? Pass someone, Ethan. Emilio. Mean. Hands if you agree with that. Yes, of course, this one is for what? Sample, and this is for population. And last but not least, notice that these are the same, this one and that one. All right? So, what does that stand for? Emilio, pass someone. Alex. Not the total number, but the number, because today we're going to be comparing one number of a data set with the entire measures, okay? So this is the actual number. We're going to pick one number on the data set to compare with the other, okay? So, sample, population, okay? So, now that you have 2 new formulas, we have a total of what, 21 so far? Ooh, let's go. All right? So check this out. Write your utensils down, look up to the screen. It reads, a student scored 65 on the statistics semester 1 final test that had a mean of 50 and a standard deviation of 10. She scored a 30 on the semester 1 history test with a mean of 25 and a standard deviation of 5. Compare her relative positions on the 2 tests, which means we have to come to a conclusion. Okay? So, we're going to get started with this one. We're going to do this one together since it's very simple to follow. but I want you to copy this one at least so you can have this as example for your home, please. Copy that on your paper, please, on your notes. No, just copy the black text. All right, here we go. So, I'm starting with blue. I'm going to underline the first information given for the statistics semester 1 final. So, the student scored 65 on what? Statistics semester 1 final test. Okay. With a mean of 50 and a standard deviation of 10. So let me write my formula. Z equals X minus X bar over S. I'm going to rewrite it again. Z equals blank minus. So, as you're writing it down, look at what we boxed on the first portion of the problem and tell your neighbor what goes where. What goes where? What goes where? All right, you should know what goes where, yes? So, what is X? Alex, 65, so we're going to label this one X, which means the X bar is what, everyone? 50, so this is our X bar, and of course this is our S. Okay, so 65 minus 50 divided by 10. Therefore, this is 15 divided by 10, which is 1.5. All right, and this is for the what? The statistics semester 1 test. Okay, so let's do our bell curve. So, our mean, we said it was 50, okay, 50. So, what would be our normal range according to the data given? Tell your neighbor what would be the normal range between what and what? What would be our normal range? Normal range. Tell your neighbor, please, normal range. Normal range. All right, normal range. Let's see, how about Sean? What was our normal range? 40 and 60? That is correct. Hands if you got that. Yes, because we're at 50 for the mean and the standard deviation is 10. So 1 up is 60, 1 down is 40. That's our normal range. Okay. So with that said, tell your neighbor what would be second standard deviation. What would be the scores for the second standard deviation, which means above norm and below norm for the. All right. All right, Alice, go. Second standard deviation. 30 and 70, that is correct. So far so good, yes? And the last one, the third deviation would be between 20 and 80. Okay, so we good? However, now we want to know, check this out, being that this is measured of position, where does this score, where does it land compared to the rest of the class in that bell curve? The exact position. So, what number did we come up with? 1.5. That means 1 full standard deviation and a half. So here's my 1 full, half, so that score is about right there. Z-score of 1.5. 1.5. It's 1.5 standard deviation. So the 65 scores somewhere right here. So think about it. If this is the norm, what would you say this person scored in regards to their statistics final? What would you say? Above average, right? Or above the norm. So that means this person knows what they're doing in statistics. All right, let's go to the next part. I'm going to switch to green. She scored 30 on what? Semester 1 history test with a mean of 25 and a standard deviation of 5. So let me get you started with the formula. All right. All right, so find me that z-score, and underneath, we're going to sketch a new bell curve. Fill that in. I'll give you some time. And then we'll come to a conclusion comparing both tests for this student. Copy and go. All right, so your formula should look z equals 30 minus 25 over 5, which is 5 over 5, which is 1. So our mean was 25. Our first standard deviation is between 20 and 30. That's the norm. Then we go 15 to 35. And then 10 all the way to 40. And did you got something like that? Yes? Okay. So second standard deviation, third standard deviation, second standard deviation, third standard deviation. All right. So, however, what was the score? The score was 30. Where does that fall compared to the other tests in her class? At what? 1 standard deviation. So that means it falls right on the standard deviation right here. That's the z-score of 1. So, comparing the two of them, now, comparing the two tests, tell your neighbor a conclusion for her 2 tests. Comparing the two of them, what would be your conclusion? Conclusion. All right. Conclusion. Bree, go. The student is above the norm Is this one above the norm? So comparing the two tests, the student is above the norm in statistics and at normal range in history. 10Q. Hands, if you agree with that conclusion? Yep. From 1 to 5, how comfortable are you with these scores up to right now? Okay, 5, 5, 5, 4, okay. So, Just to recap, look up to the screen. According to the formula, what information did we need? The number that we're going to compare to the rest of the data, that's X. What else did we need? The mean. We need a mean of the data. And last but not least, what else did we need? Standard deviation. Those three components. Now let me show you another way of the way that they're going to present this. Look up to the screen. That's another way of presenting it. Look at it. Do we have enough information to compare the two tests using formulas? Yeah, because we have the data, we have the mean, and we have the standard deviation. Well, that's good and dandy. And at this point, I would give you the home plate, but we're going one step further. Look up to the screen. What if you got data that look like this? All right, look at it. So here's a student in statistics. This is what they scored on the quizzes, and this is what they scored on paper. Now, if I wanted to compare, first of all, the two data, but I wanted to compare the lowest score on each, this one and this one, using z-scores. Tell your neighbor, what do you need to do in order to use your formula for that type of data? First for this one, and then for that one. That means we need a bell curve for that one and a bell curve for that one. So, we need the data number. Do we have it? Did we identify it? Yes, for both. What else do we need? The what? Yeah, we have the numbers. What else do we need? Mean. What else do we need? Standard deviation. Do you know how to find the mean and the standard deviation for both sets? Yes. So at this time, with one color, do this portion, do your bell curve. With another color, do this portion, do your bell curve. And then from there, come to a conclusion. And at the end, I'll call on someone to give us a statement for their conclusion. Go. All right, let's see for the first set of data. What is our mean, Alice? 90. Hands if you got 90. That is correct. How about the mean for the second set of data, Alex? 85. Hands if you got that. That is correct. So now you just need the standard deviation. I'll give you guys a little bit more time. And once again, you're using a different color for this one, and it's bell curve, and this one. It comes off a little bit. Yeah, just a tiny bit, because it's not as accurate as going the long way. So you should have written 70 minus 90 over standard deviation. Wow. All right, 70 minus 90 over standard deviation. What'd you get for standard deviation for the first one? Ethan, what is it? 11.4? 11.4, hands if you got something close to that. Standard deviation, yes? So our S was close to 11.4. Now, just a quick FYI, some of you are using the shortcut formula, some of you are using the long way. So there's going to be a little bit of disparity in regards to the decimals, which is fine. So we'll go with this. So this is negative 20 divided by 11.4. So this is approximately negative what? See, calculators, negative 20 divided by 11.4. Negative 0.75. 1.75? Like that? All right. So, bell curve. Our mean is at 85. No? Oh, my bad, 90. Sorry. 90. Yeah, I did that on purpose to see if you were paying attention. Let's go. 90. And then one standard deviation. Let's see. We are at here and here. So that takes us to 11.4. That's 101.4. And over here it's at 79.6. 79, is it 78? Oh, 78. 78.6. Okay? Here's one more standard deviation and another standard deviation. So, all right? So, what was our z-score for this one, guys? -1 3/4. So where's my negative standard deviation? Right here. And then the second negative standard deviation is right here. So 3/4 of the way to get to that is about right here. That's our z-score of -1.75. And that one is for the test that they scored at what? At 70. So what do you guys notice? What? It's somewhere way over here compared to the rest of the class, yes? And do you know what to do with this right here, yes? Once you get your bell curve for this one, you compare the two, come up with a conclusion, and that's how you compare z-scores on these. Okay? We'll stop right there. From 1 to 5, how comfortable are you with this so far? Yeah? 23, thank you. I like that. Yeah? 5 4s, 5 4s. So your home plate, I'm not going to give you any of these where you have to come up with all the components. It's just straightforward where they give you the 3 components, substitute into the formula, and just do the practice. Okay? All right. Have a good one. Bye.